So now in this video, we'll be seeing two important another theorems related to circles, arcs and chord. Let us start with the first theorem. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. I'll again repeat it. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Let us see what this theorem means and how to apply and the proof everything related to this theorem. Say I have 2 points lying on the circle P and Q. Say this point is S and here we have Q. So as you can see here, if I'll join PQ, I'll get the chord of the circle PQ. PSQ will be my major arc and P, say this point is R, PRQ will be my minor arc. As per the theorem, it says that the angle subtended by an arc at the center, that is, say this angle is 2 theta, the angle subtended by the arc at the center, that is 2 theta, is double the angle subtended by it at any point on the remaining part of the circle. So now this arc PRQ subtends this angle at the circle, and if this is 2 theta, this will be double of this angle. So if it is 2 theta, this will be theta. So this is what this theorem says. Let us see some other different point of views of the same theorem. Now see, now we have, say this is point P, this is point Q, and this is arc. PQ will act as the largest chord of this circle, that is the diameter. Now we know that this is 180 degrees. If this is 180 degrees, this should be double this angle subtended by the same chord on the circle. So that is why this will be 90 degrees. Similarly here, if say this is 2 theta, then this angle will be theta. That is, the angle subtended by the arc on the circle is all at the center is double the angle subtended by it at any point on the remaining part of the circle. Now let us see the proof related to this theorem. But before coming to the proof, there is one more theorem which is basically the applications of first theorem. The theorem says that angle in the same segment of a circle are equal. That is, now we have PQ. The PQ chord divides the circle into two segments. This portion is the major segment and this portion is the minor segment. So it says that if say this angle is theta, then this angle will also be theta. And you draw whatever you want, that angle will always be same as theta on the same segment. Even this will be theta. If I draw here an angle at the same points P and Q, this angle will also be theta, and so on. So this theorem proof of second theorem is relatively easier. So let us start with the proof of the first theorem. So what we'll do here, let us draw a circle first. I have a chord PQ. Let me join it, PQ, and let O be the center. Now as per the theorem, it says that if angle POQ is suppose some angle, then this will be this value of angle POQ will be twice angle, say this point is R, PRQ. Let us see how this happens. I'll join R with O and extend it further a bit. So I have two triangles here, angle PRO and triangle QRO. Now let us assume that, say this angle is something, I don't know the value, maybe let us say call this angle as X. Now you know that this angle X is the exterior opposite angle of this angle and this angle. Now if I'll ask you, what will are both the angles will be same in measure or will it be different? See very carefully. OP and OR are the radius, so both will have same values, and you know that angles opposite to equal sides have equal value. So let us say if this is Y, this will also be Y. So since X being the exterior opposite angle, I can write X is equal to Y plus Y, that is X is equal to 2Y. Similarly, let us say that this angle is Z. OR and OQ again being the radius of the same circle, so they will have the same measure, and angles opposite to equal sides have equal measure. So let's say this angle is A, then this angle will also be A. So I can say Z is equal to A plus A, that is Z is equal to 2A. Let us call this equation 1 and this as equation 2. Now angle POQ is nothing but angle X plus angle Z, right? And angle PRQ is nothing but angle Y plus A. Now let us see the relation between them. What I'll do, I'll add equation 1 and equation 2. So I have X plus Z is equal to 2Y plus 2A, which finally gives me X plus Z is equal to 2 times Y plus A. And what is angle X plus Z? Angle POQ. So angle POQ is nothing but 2 times angle PRQ. This is what we started with, and this is the proof of this theorem. Next theorem, relatively easy. The proof of this theorem is simpler. What we'll do, we'll just draw a circle. Now I know that if I have a chord PQ here, and let us draw an angle and join PQ with the center, I know that if this is 2 theta, this will be theta. Similarly, if I draw the angle from the same chord, I know that if this is 2 theta, this will again be theta. So whatever angle you draw at any point on the circle from the same chord, it will always measure theta, and at the center it will measure twice the value of theta, that is 2 theta. That is the proof of the second theorem. So now I think that both the theorems are pretty clear, and these are the actually important theorems as far as circles is concerned, because these things that this is 2 theta and this is theta will have wide application while solving questions related to circles.